Hydrogen gas is a promising potential fuel for use in near-zero emissions vehicles. In order to realize a hydrogen economy, a refueling infrastructure is needed. Typical components within infrastructure include compressors, actuators, valves, regulators, and hoses, many of which include some combination of metal and polymer materials. While the majority of metals used in these components have been heavily studied for their compatibility in high-pressure hydrogen environments, there has been relatively little work studying the impact of high-pressure hydrogen on polymer compatibility. Friction and wear properties of polymers under high-pressure hydrogen are potentially very important to understand when designing dynamic seals and components. Effects from hydrogen may be greater than those in metals due to a polymer's lower density and susceptibility to small molecule diffusion. In this video, we will describe an in situ test methodology that we have developed to measure the wear and friction properties of polymers under a high-pressure hydrogen gas environment up to 4,000 psi. A note of warning. This experiment requires the use of hydrogen gas under high pressures and requires extreme caution. Hydrogen gas is odorless, colorless, and thus undetectable by human senses. Hydrogen is highly flammable and burns with a nearly invisible blue flame and can form explosive mixtures in the presence of oxygen. High pressures in excess of 1,000 psi add additional explosion hazards that must be appropriately planned for in preparation for any testing. This amount of stored energy represents a serious safety hazard. Therefore, due diligence, planning, and safety evaluation must be performed before starting such an experiment to ensure that these hazards are mitigated. The experiment presented here is performed in accordance with appropriate